What does the Falcon 9 usually launch? Satellites? Spacecraft? That's right. But beyond imagination, it will launch an entire space station, something never seen before. Haven 1 by VAST. This will be the very first privately owned space station to be launched intact in a single go. So, what are the features of this station? And here's the crucial question. What is SpaceX's true role with this space station? Is it just about transportation? Let's find out in today's episode. Haven 1 will be one of the most minimalist space modules, yet it's packed with scientific and practical purposes. Its cylindrical shape is a common design choice for modern space station modules, not only optimizing interior space but also ensuring structural integrity under the immense pressures and stresses of the space environment. With the tension caused by microgravity and external pressure, the cylindrical form provides optimal strength, allowing the module to withstand the harsh conditions of space. At the top, Haven 1 features a rounded nose fitted with an observation dome. This dome window offers breathtaking views, suggesting that Haven 1 is not just for research, but also for leisure. After all, this is a private space station, and its goals will definitely encompass space tourism. A key feature to note is that Haven 1 has only one docking port, located at the center of the module's rear. This compact, circular docking port is equipped with multiple sensors and mechanical latches to ensure a secure and precise docking process. It allows only one spacecraft to dock with Haven 1 at a time, meaning the station can accommodate a maximum of 4 crew members per visit. This makes Haven 1 an ideal choice for mid-scale missions, offering a unique, straightforward, and efficient experience. In terms of size, Haven 1 boasts a diameter of 3.8 meters and a height of 10.1 meters. This gives it an interior volume of about 80 cubic meters, ideal for crew habitation and conducting research. The module is expected to weigh around 14 tons, though relatively compact, essentially a mini space station. Haven 1 has been perfectly optimized to fit within the payload capacity of SpaceX's Falcon 9 rocket. Power for Haven 1 is sourced from large solar panels mounted symmetrically on either side of the module. These panels capture energy from multiple angles as the station orbits Earth, capable of generating up to 15,000 watts of electricity. Haven 1 will orbit at an altitude of approximately 310 miles, nearly 500 kilometers, above the Earth's surface, slightly higher than the International Space Station, ISS. VAST has boldly declared that they plan to launch Haven 1 no earlier than August 2025. Once deployed in low Earth orbit, 4 commercial astronauts will be transported to Haven 1 by SpaceX's Crew Dragon, and will spend about 30 days on the station before returning to Earth. It's a bold plan with an incredibly fast timeline. Jed McCaleb, founder of VAST, admitted in an interview with Ars Technica, "It's a super aggressive schedule, but we have a clear path for how we're going to get there." Founded in 2021, VAST leaped into the industry with an incredibly optimistic timeline. With fewer than 200 employees currently, building a fully operational, human-rated space station within a few years is nearly unbelievable for a startup. So why are they so confident? Even though there's been no official word on SpaceX's involvement in the Haven 1 project, it seems SpaceX's role might extend beyond merely launching Haven 1 and ferrying astronauts with Crew Dragon. Looking at the design of Haven 1, I immediately noticed significant similarities between this module and SpaceX's Dragon XL, a proposed upgrade of Crew Dragon that SpaceX has announced but has yet to officially debut. Dragon XL was initially intended to support cargo missions to Gateway. However, SpaceX has been extremely tight-lipped about the progress of this variant, and many believe that SpaceX may have shelved or redirected the Dragon XL project towards other goals. The striking resemblance between Haven 1 and Dragon XL suggests that VAST might have leveraged some of SpaceX's research and development from the Dragon XL project to create their own module. This could explain how a relatively new player like VAST is making rapid strides in an industry where hardware development can take years or even decades. Take a look. The diameter of Haven 1 is strikingly similar to Dragon XL's, around 3.7 meters, which is also the diameter of the second stage of the Falcon 9 rocket. Industry rumors suggest that SpaceX planned to use the production tools from the Falcon 9's second stage to build Dragon XL. Maybe the design and development process for Dragon XL has seamlessly been transitioned into creating Haven 1. The renderings of Haven 1 reveal a cupola dome window that closely resembles the one SpaceX used on its Dragon spacecraft during the Inspiration 4 mission. This is a significant detail that highlights a close technological link between SpaceX and VAST's module. In fact, the connection between VAST and SpaceX goes beyond mere design similarities. The senior leadership and advisory team at VAST include numerous former SpaceX executives. For instance, Garrett Reisman, SpaceX's Director of Space Operations, brings a wealth of experience in managing space missions. missions, and an intimate understanding of SpaceX's technology development processes. Then there's Hans Königsmann, former vice president of mission assurance at SpaceX, who played a crucial role in ensuring the success of SpaceX's rocket and spacecraft missions for many years. We can't forget Will Heltsley, a leading propulsion expert who was vice president of propulsion at SpaceX for 12 years. His extensive experience in propulsion systems is a significant asset for VAST. And Jake Burnett, who played a direct role in testing and deploying Crew Dragon missions, including Demo 1, Demo 2, Crew 1 through Crew 7, Inspiration 4, and Axiom 1 and -2, is also a key member of VAST's team. With nearly a decade of work in Dragon's production testing department, Jake has deep insights into the critical systems of the spacecraft. With such a powerhouse team behind it, VAST's approach to developing Haven 1 certainly has a strong foundation. The names mentioned are just a few of the key players who have transitioned from SpaceX to VAST. This strengthens the possibility that SpaceX is not merely supporting the transportation and launch of Haven 1, but could also be behind many crucial aspects of the station's design and development. If the hypothesis that Haven 1 is built on the Dragon XL foundation holds true, it would explain why VAST has made such rapid progress in developing a space station. What we're seeing with Haven 1 might be the result of leveraging the research and development from Dragon XL, effectively turning those efforts into a fully fledged space station. This not only allows VAST to save considerable time and resources, but also helps SpaceX maximize and utilize previously developed technologies. You might think Haven 1 is just another space module, but it's far more significant than you might imagine. The most exciting aspect of Haven 1 is that VAST plans to conduct the world's first artificial gravity experiment on this space station. Specifically, VAST will create a sensation of gravity in space by using centrifugal force, a concept usually relegated to science fiction or theoretical experiments. When an object spins around its axis, centrifugal force pushes everything inside away from the center, creating a sensation akin to gravity, even though you're still in a weightless environment. Haven 1, with its cylindrical design, is meticulously configured to test this phenomena, serving as a groundbreaking platform for experimenting with different levels of artificial gravity, ranging from 0G, zero gravity, up to 1G, Earth's gravity. This opens up an extraordinary capability. Scientists can conduct experiments under varying gravitational conditions, like the Moon's gravity, 0.165 G, Mars' gravity, 0.376 G, or even customized gravity levels of their choosing. These experiments aren't just about understanding how physical and biological factors behave under different gravity levels. They also pave the way for exploring the potential for living and working on other planets, from testing equipment and materials to studying biological responses. All of this research is crucial for preparing humanity for long-term planetary exploration missions. Especially, Haven 1 is not just VAST's first commercial space station. It's also a strategic proof of concept. The existence of NASA's Commercial LEO Destinations (CLD) program is a crucial factor here. This program aims to develop commercial space stations in low Earth orbit. With what VAST is doing, it's highly likely they will join the CLD program once Haven 1 is completed. Scheduled to host only 2 visits from SpaceX's Crew Dragon spacecraft, Haven 1 is designed as a stepping stone, a laboratory in orbit where VAST can learn and refine their approach. Because VAST's ambitions don't stop with Haven 1. Their ultimate goal is to build a space station with an enormous artificial gravity capability, with an internal volume of up to 3,500 cubic meters. That's 3.5 times the volume of the International Space Station. This bold concept could revolutionize how we live and work in space. In reality, VAST has embarked on this ambitious plan, clearly pushing the boundaries further than most private space companies can even imagine. It's incredibly ambitious and exciting. But this raises a big question. Could SpaceX be quietly supporting VAST's efforts to develop this massive artificial gravity space station? Do you think SpaceX might also be secretly working on their own colossal private space station? Share your thoughts below. All right, that's it for today. If you enjoyed this video, please give it a thumbs up and subscribe to our channel for more in-depth looks at the latest advancements in space technology. Thanks for watching, and I'll see you next time.